Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 1, Lesson 6. Let's get started. So here we have the laws of exponents that we've been working with. So these should be very familiar to you. We've been working with those throughout the topic. And down below we're going to be using these three facts in our exercises today. So I'll bring those to the slide when we need them, and then we'll move forward with each of the next four exercises. Okay, so let's go to exercise 1. We're going to show that C, which is this from the first slide that we looked at, is implied by equation 5 of lesson 4. I'll show you that in a second, where m is greater than 0, and explain why C continues to hold even when m is equal to 0. So we're going to make m equal to 0, and we're going to show that this equation still holds true even if m is equal to 0. So let's start with taking this 1 over x all raised to the m power is equal to, well, remember this would be 1 to the m over x to the m, because we know that this exponent will go to each the numerator and the denominator. So that's our first change here, and then we can see that any exponent here, that 1 raised to any exponent is going to mean repeatedly multiply 1 some number of times, and that's just going to mean 1 times 1 times 1 times 1 times 1 so many times. Well, no matter what it is, it's going to be equal to 1. So we know that this is also equal to 1 over x to the m. So there's our first move, and then next we will bring this original expression down, which was 1 over x all raised to the m power. So we know that these two are equal to each other. So now let's talk about the left side. If we are to make m equal to 0, then we would have, let's do the left side over here. We would have 1 over x raised to the 0 power, and we know that anything raised to the 0 power is equal to 1. So we get the left side is equal to 1. Okay? And then if we go to the right side and we say that m is equal to 0, then we would have 1 over x to the 0, and then we know that anything raised to the 0 power is 1, so we have 1 over 1, and then 1 divided by 1 is equal to 1. So we have proved that both sides are equal even if the exponent is 0. So we know that for positive exponents this is true, and now we've just proved that for an exponent of 0, it also holds true. All right, let's go to exercise 2. We're going to show that B, which is this, we need to say that B is in fact a special case by rewriting it as x to the m to the negative 1 is equal to x to the negative 1 times m for any whole number m, so that b equals m when it's a whole number and a equals negative 1. So let me show you what we're talking about here. We have x to the negative m is equal to 1 over x to the m. And let's look at the left side first. So let's look at this x to the negative m. X to the negative m is also equal to x to the negative 1 times m. So this negative 1 comes from the coefficient here in front of your variable, which has to be a -1 because -1 times m is -m. So we can just break that out a little bit so that we show that that these two are equal. These are the same thing. And then on the right side, let me change my color here. On the right side, we have 1 over x to the m. And remember, we can change this to a reciprocal by taking x to the -m over 1. So when I take the reciprocal, remember the sign changes here, and now I have just x to the -m. So that would be x to the -m, and we again can break that out so that it says x to the -1 times m. So you can see that on the left side we have x to the -1 times m, and on the right side we have x to the -1 times m. So again it holds, and we have an equivalent equation. Okay, so there's exercise 2. Exercise 3. Again, we're going to use case C to prove this as a special case by rewriting C as x to the -1 to the m power is equal to x to the m power times -1. So let's look at the left side first. I can take this 1 over x and rewrite it as x over 1, where x is raised to the -1 power. Because I took a reciprocal, since I took the reciprocal, that's going to give me a -1 on the x. Okay, so this is actually all of this, but what happens is x to the -1 will stay, and 1 to the -1 is just 1, so 1 over 1. So I have here x to the -1 on the left side. Okay? And that is all raised, remember, to the m power. And then, because we know that we have an exponent raised to another exponent, that we can multiply those exponents. So I get x to the -1 times m. So that's what we were looking for, x to the -1 times m on the left side. On the right side, let's see, we have a 1 over x to the m power. And again, if I take the reciprocal, this is going to be x to the -m over 1, which is the same as x to the x raised to the -m. And again, from our last exercise, now we can say that x is -1, that's the coefficient, times m, that's the exponent. So now we see that these are the same once again. All right, moving on, exercise 4. We have to prove that x raised to the b to the a power is equal to x to the a times b power. And in order to do that, we're going to look at when a equals -c. So this is the difference. We're going to change that exponent of a from a positive exponent to a negative exponent. Okay, so let's look at the left side. On the left side, we have x to the b, all raised to the a power. And we know that when we substitute a, then we're going to have x to the b, all raised to the -c. So all we did was this. We took this, we said a is going to be equal to -c, so we made that change. Okay? And then from there, we know that a negative exponent here can be changed into the reciprocal, changing that to a positive exponent. So we would have x to the b. Oops, I'm sorry, I forgot my reciprocal. We have 1 over x to the b raised to the c power. So now my exponents are positive. And since we know that an exponent raised to another exponent, we can multiply the exponents, I would get 1 over x to the b times c. So 1 over x to the b times c on the left side. On the right side, we start with x, where is it? X to the a, b, and we're going to replace a with a negative c. So we would have x to the negative c times b power. And then we know that since this is a negative exponent, we can rewrite that as 1 over x to the positive, and I'm going to rearrange the order in alphabetical order, 1 over x to the bc, and there we have it. 1 over x to the bc is equal to 1 over x to the bc. So it works even if we have a negative exponent as well. Okay, so lots of letters in this lesson and proofs, but you should be able to manipulate exponents using the laws of exponents in your practice today. That is lesson 6. I hope that helps. I'll see you again next time.